Hi there, this is Bill Punch again, another of a series of videos from Michigan State University, Introduction to Computer Science using Python, CSE 231. Today we move on to a new topic, the topic of strings. We'll have a couple of videos concerning strings, but this will be our introduction to strings, laying the basic groundwork for the stuff we're going to do later. Let's go ahead and get started. Alright, so the string, whose official name, just like anything else in computer science, has a shortened version, str, is our first collection type. A collection type is a type that has more than a single item stored in it. A float has a single value, an int has a single value, a boolean has a single value. But a string has a set of characters, multiple characters stored in the string. One thing for you C++ and Java programmers, there is no character type in Python, right? Even a single character is still considered a string. In fact, a string is a little more restrictive as a collection. It's a sequence because not only are there elements, but there's an ordering to the elements. Not all collections are sequences, but every sequence is a collection. We pretty much know how to make a string. Let's go ahead and run through all of them really quickly. So we can use single quotes as long as we use the same quote every time, right? So we can begin and end with a single quote. We can begin and end with a double quote. We can take something and apply the str function and turn it into strings. Here's a new one. We haven't seen this one before. This is the triple quote. If you have three quotes, then the end of line, the carriage return, will be preserved in the string. So we can do an entire string as a whole paragraph, and it will be stored as a single string. Let's go ahead and run that. And if I evaluate then what's the value of this thing called the fourth string, it'll have, and we'll talk about this in a second, these two strange characters, \n and \n, which are essentially a representation for the carriage return in the string. And when we print it, it will print with multiple lines. Just so you know, even that string, if we were to print its type, is in fact of class string. Right? Even a single character, that's the official name. So let's look at those odd characters. When we put a \n in front of it, in front of a particular character, we're trying to represent non-printable characters, characters that show up on the screen as some kind of control. The three that I think would be most useful is \n, a single character. So two things that we type at representing a single character is a carriage return. \t, a control thing. Again, not printable, but sets up spaces, two characters representing a single action, the tab character, and then \, single quote to represent a single quote, which comes in kind of handy when you're typing strings with apostrophes or the like. So here's a particular string, and what I'm saying here is that I want to start and end with a single quote, but I want to include a single quote in the string to differentiate that. Here's a single character that's placed into the string, \quote. If we evaluate that, we see that, in fact, that's exactly what we get. We get that quoted string included in the string. Some operations we can do on string. We can measure the length of a string. Here is hello world, and the function's name is length, and unfortunately shortened to len, just like anything else. So length, which takes as an argument a string, will return an integer value, how long it is. How long is hello world? It's 11. If you were counting 10, remember that the blank character, which is included here, also counts as a character. There's some binary operators we can perform on strings. Plus, with a string, means and this is maybe an unusual word, concatenation, to sort of put two things together. Better to show you than to say, perhaps. So if I take my string, which is hello space world and space and friends, and concatenate them together, I get a new string, hello world and friends, a single string. And notice that the original string is unchanged. So a new string was created by the concatenation. The old string is not modified. Multiplication. So I can take a string and an integer and multiply them together, and that means repeat it the integer number of times, returning a new string. So if I evaluate this guy, spam space repeated 3 times becomes spam, spam, spam. And again, note that the original string is not modified. So a new string is created, the original string not modified. So plus concatenation star, repetition. And it's important to note that it's weird what plus and star might be because it really depends on the types of the arguments that we're working on to say what the operation is going to perform. And there's a word for that in computer science, and it's called an overloaded operator. An overloaded operator means that the function that is performed depends on the types of the arguments, and this is easily shown right here. What is the result of 1 plus 3? Two integers and plus, that's addition. If you take a string 1 and a string 3 and add them together, that's concatenation. What do you get? 1 plus 3 is 4. Concatenation, 1 plus 3 is 13. So depending on the types, it's difficult to know what the operation will do unless you know what the types are. Another set of operations that are useful is membership. Again, let's assume that the string is my hello space world. The membership operator is the in operator. You'll see that in all of these examples. And the in operator returns true or false. And it looks for some element in the sequence. And so the first one is the string H in my string. Clearly it is. So it should return true. Is the sequence LLO in the string? Clearly it is. And so that operation should also return true. Is the sequence LLOO? Is that anywhere in this sequence? It is not. This should return false. Is lowercase h in this string? Let's go back and look at hello world. Nope. There is no lowercase h anywhere in this thing. There's an uppercase, but case matters in Python, and little h is not the same as big H, so this is going to be false as well.